Hi everyone, this is Anand Kumar from Metropolitan Institute of Technology. The project that we have done is Smart Waste Management System for Metropolitan Cities. We are glad to present our project. In order to control problems that disturbs health in environment, we should avoid lumping of wastages on roadside. So creating a neater and cleaner environment by eliminating the overflow of wastages outside the bin by regular cleaning of dustbins becomes mandatory. This in turn helps us to lead a healthy life. Thus, waste management technique becomes essential. Now let's look into our project. The idea that we took to implement is, say suppose there is a city with several localities. The sanitary worker in each locality will be given a username and password. So say here for Astinabaram, Kumar Nagar, Shobika Nagar, the sanitary worker will be given a single username and password. Similarly, Maninagar, Periyar Nagar, Barni Nagar, which comes under Pallavaram, will be given a single username and password. When any of the bin inside Chrompet gets full, it will be notified to the respective sanitary worker who is responsible for that. So each bin will be given an ID. So the receiver side, the notification comes along with the bin ID. So a single sanitary worker can clean the entire locality in an efficient manner. Now let's look into the project how it is done.
Hi everyone, this is Saran. Firstly, to start with, we use WalkV for simulation using ESP32. The sensor we used is ultrasonic sensor. This is used to measure the level of the bin. We also measure the weight of bin. The level the bin can hold is 400 cm. The weight the bin can hold is 100 kg. We have used a servo motor which is used for locking and unlocking the bin based on whether the bin is full or not. We have used 3 LED. The green one which indicates the bin is ready to use. The red one indicates the bin is full, so it should not be used. The orange one indicates that the sanitary worker got notified and he is on his way to pick up the garbage. We have written the code and simulated the project. So the level of bin is about 350 cm. It has to be notified to the authorized person and the bin has to be locked. And after cleaning, the bin has to be disclosed and green light should be glow.
Hi, this is Prasanna. We are going to see how we could interface IBM Watson IoT platform with WalkV. So first of all, we have to create an ID in a IBM Watson IoT platform where we could see org ID as NY6NKK, and then we have to create a device with the help of add devices. We have to give a device ID, device type, and then you have to give a API key which will be used later in Node-RED. We have given device ID as smart waste, device type as ESP32. With this with the help of this we could interface with WalkV. So after interfacing we could see the status as connected, and then we could see the data published in recent events. After that we could move on to Node-RED. So when in Node-RED we have to create account in Node-RED, and then we could create a new flow, and then we have to install some package in manage platform. Then we have to drag some nodes into the flow. So first of all we have dragged IBM IoT, which is an input response node, which comes where the data will be come from the IBM Watson IoT platform. Then we have weight and level, which is a function used to separate the values from the JSON format from the IBM IoT platform. Then we could see the event. The event is used to publish the data, both the weight and level, through a URL. And then we could see command. Command is an output response node from the MIT app inverter. When we be using the app, we could send and response from the app to the WalkV. So those commands will be flow through this command control and then to IBM IoT. The light on and light off is used as a button in web UI, where this is also an output response node which will be flows from web UI to Node-RED, then to cloud, then to WalkV. Thank you.
Hi everyone, this is Manoj. Let's look into what happens in the MIT App Inventor. MIT App Inventor is a free open source web app that anyone can use to build mobile apps. In MIT App Inventor, there will be two options. One is design and other is block. Design is used to design the front end, and block is used to code the back end for the designed front end. Let's look into the app now. This is the front screen. The garbage level and the weight of the bin is displayed here. The username and the password which is given to the sanitary worker is entered. Based on the level, whether the bin is full or not is notified along with the bin ID. In order to know the location of the bin 1, click the necessary button. Bin ID along with the location is mentioned. And using the map given below, location can be known by the sanitary worker. There will be a button which has to be clicked by the worker when he starts his trip to empty the bin. And there is a button which has to be pressed after emptying the bin. Thank you.
Okay, now let's look into the demo. In this working simulation, first of all, green light glows, right? It indicates that the garbage bin can be used. The below output, we can see the weight as well as the level, right? These data has to be sent to the IBM IoT Watson platform. See, the weight and the level of the garbage bin is published in IBM IoT Watson platform as well. These data has to be sent to the Node-RED. Here in the Node-RED as well, we get the weight and the level of the garbage bin, which in turn is sent to the MIT App Inventor. That is, we have designed. Data can also be made to publish in the web UI as well. Web UI, we have two gauges for weight and one for level, and we have two buttons. Now let's assume that the garbage bin is full. This I am changing by using some changes in ultrasonic sensor. Now one can notice that the green light glows off and red light glows. See that the servo motor makes the garbage bin to be closed. The same thing is reflected in the web UI as well. So according to the changes that is caused in the dustbin, we can get the data published in IBM Watson platform, web UI, and MIT App Inventor as well. You can see the changes. The weight now is 9 and the level is 374, and the bin is full, so it's publishing that the bin is full and red light is glowing. Here the yellow light is glowing, right? This is because the authorized person has noticed it and he is on his way to collect the garbages. After collecting the garbages, the green light glows and the servo motor goes to its own place. That indicates that the garbage bin is open. You can also notice that in web UI also. As you click the got notification button, yellow light glows. Click the empty bin, like bin is empty, the yellow light goes off. Let's have a look at the MIT app. I have changed the ultrasonic sensor that the garbage bin is full, so it is showing like bin 1 is full. Here 1 is the ID for the bin. So in order to know the location of the bin, click no location option. It will take us to a page where the location of the bin along with the bin ID will be shown. You can also use the map to locate the garbage bin. Now the sanitary worker starts a trip to empty the bin. He has to click the necessary button. This will be shown at the garbage end side by glowing the orange light. It indicates that the garbage is full and the authorized person is notified that the garbage is full. Again, if the sanitary worker clicks the button like the garbage is emptied, the orange light goes off. You can see this. The same thing can be done using the web UI also. Let's have a look at it. If he or she clicks that got notification is full, orange light glows. When he or she clicks button like after the bin is emptied, the orange light goes off. And yeah, that's it. Thank you.